Hi guys, Mrs. Venti here. Welcome back to my channel. This is our second video on trigonometry and we are going to start on exercise 1. Our first video was an introduction where we learned how to label the triangle and how to use the sine, cosine and tangent ratios. So in today's video we are going to do the exercise 9 which is found on page 163 until 164, and we can apply everything we learned from the previous video to different questions. I'm using the Mind Action Series textbook for grade 10. Please like and subscribe. Let's get started. Question A is saying, in the triangle, angle N is 30 degrees. Line segment MN is 8 units. Line segment MP is 4 units. Line segment NP is square root of 48 units. Use the sketch to write down the values of the following trigonometric ratios. Simplify the ratios as far as possible. So question number 1 says, what is sine of 30 degrees? Question number 2 says, what is cos of 30 degrees? And question number 3 says, what is tan of 30 degrees? Those are the questions that we are going to answer on this page. So let's get started. You know that sine of an angle is opposite over hypotenuse. You know that cosine is adjacent over hypotenuse. And you know that tangent is opposite over adjacent. Now do remember that these fractions need to be memorized by you. We're going to use it so much you need to know it off by heart. So sine of 30 degrees is opposite over hypotenuse. Here is my 30 degrees. The line segment that is opposite 30 is 4. So that's going to give me 4 over a hypotenuse of 8. And if I simplify that, 4 over 8 is the same as 1 over 2. Sine of 30 degrees is a half, 1 over 2. Cos of 30 degrees is adjacent. Adjacent is going to be this line that is on the same line as my angle, which is going to be square root of 48 over hypotenuse, which is 8. Now if I use my calculator and I check, I already know that the square root of 49 is 7. So the square root of 48 is not going to be a perfect square. If I divide that by 8, I do not get a perfect fraction. So this is as simple as it gets. I will not simplify it any further. Next up, I am doing tan of 30 degrees, which is opposite. I know that to be 4 over adjacent, which I know to be square root of 48. And those are the answers to question A. Question B says, in the sketch alongside, angle C is theta, angle AB is 8 centimeters, line AB is 8 centimeters, and line BC is 15 centimeters. Question number 1 is asking us, calculate the length of AC, that length there. So we know this to be the hypotenuse. And then question 2 is asking us to get sine, cos, and tan of angle theta. So let's start with answering question number 1. We are going to use the theorem of Pythagoras. And this is valid because we have a 90-degree angle. The theorem of Pythagoras helps us to get any side if you have a 90-degree angle and the values of 2 out of 3 sides in a triangle. So Pythagoras says side squared plus side squares equals hypotenuse squared. We are looking for the hypotenuse, so we should have 2 sides. Our first side is AB, that is 8 squared, plus our second side is BC, that is 15 squared. 8 squared plus 15 squared is going to be equal to hypotenuse squared. 8 squared is 64 plus 15 squared is 225, which is going to be equal to hypotenuse squared. If I add them up, 64, I get 289 is equal to hypotenuse squared. In order to get hypotenuse, I'm going to square root the square. What I do on the right, I do on the left as well. So the hypotenuse is going to be equal to the square root of 289, which is equal to 17. Hypotenuse is equal to 17. So that is 17 based on our answer. Now question 2 starts with what is sine of theta. Sine of theta is opposite over hypotenuse, which is, if this is theta, this is my opposite, 8 over 17. Those cannot really simplify any further, so I'm going to leave it alone. That's as simple as it gets. Next question, what is cos of theta? Cos of theta is adjacent over hypotenuse. Adjacent is the one that shares the line with the angle, so that is 15 over 17. Again, I cannot simplify any further. Lastly, what is tan of theta? Not tat, tan of theta, which is going to be opposite over adjacent. Opposite is 8 over adjacent is 15. I cannot simplify it any further. And those are the questions to question B. Question C says in triangle RST, line segment RS is 8 units and RT is 10 units. What are the values of sine of R, cos of R, and tan of R? So R is this angle, and that's the one we are going to work with, right? So question A or 1 says what is sine of R? We know that sine is opposite over hypotenuse. So the opposite is an unknown value. I don't know the opposite. In order to find ST, the opposite, I need to use the theorem of Pythagoras. Notice that Pythagoras is now going to become a staple. You are going to use it very frequently. Pythagoras says that side square plus side square equals hypotenuse square if I have a 90-degree angle, which I do, so I can use Pythagoras. My first side is ST, that's the one I am looking for, plus my second side, RS, is 8, I'm going to square that one, is equal to my hypotenuse, which is RT, 10 squared. So you can calculate it and then subtract, but I'm going to subtract first. So I'm going to say minus 8 squared on both sides, meaning that I have side squared is equal to 10 squared minus 8 squared. Side squared is equal to 100 minus 64. So side squared is going to be equal to 100 minus 60 is 40. 40 minus 4 is going to be 36. Now I am going to square root both sides in order to get S alone. So my side is going to be the square root of 36, which is 6. This side is actually equal to a value of 6 units. Now I can go back to the original question, sine of R. Sine of R is equal to opposite, which I just calculated as being 6, over hypotenuse, which is 10. Can you simplify that? Yes, 2 goes into both. 2 goes into 6 3 times, and 2 goes into 10 5 times. So sine of R is 3 over 5. Next question says, what is cos of R? Cos of R is adjacent over hypotenuse, where adjacent, if this is R, then this is my adjacent line, which is next to the angle. It's 8 over 10 is my hypotenuse. Again, can you simplify? Yes. 2 goes into 8 4 times, and 2 goes into 10 5 times. So cos of r is 4 over 5. And lastly, tan of r is going to be equal to opposite over adjacent, which is going to be an opposite of 6 over an adjacent of 8. Simplify. 2 goes into 6 3 times. 2 goes into 8 4 times. Tan of r is 3 over 4. Next question. We are halfway there. Question D says, the sides of the right angle triangle have the lengths of 29 units, 21 units, and 20 units. We have angles theta and beta shown. Write the values of cos of theta, sine of theta, tan of theta, cos of beta, sine of beta, tan of beta. So let's do that. We'll start with cos of theta. Cos of theta is adjacent over hypotenuse, which is equal to, if I'm doing theta, then this is my adjacent, 21 over 29. Next question says sine of theta. Sine is opposite over hypotenuse, so opposite is 20 over 29 is my hypotenuse. And the last one says tan of theta, which is going to be opposite over adjacent, which is 20 over 21. None of those fractions can be simplified, so I'm going to leave them as that. Those are my answers. Let's do angle beta. Cos of beta is equal to adjacent. In this instance, I've got beta there, so my adjacent is the one that is part of the angle, and that's going to be 20 over hypotenuse is 29. Sine of beta is going to be, oh, I didn't write this on my cos. I said cos is adjacent over hypotenuse. Sine of beta is opposite over hypotenuse, which is going to be an opposite of 21 over hypotenuse is 29. And tan of beta is going to be opposite over adjacent, which is 21 over 20. And that is the answer for question D. Next up is question E. E says, in the sketch alongside, two of the sides of the triangle have the length square root of 5 and 3. The angles alpha and beta are indicated on the sketch. Determine the values of the following trig ratios. Tan of alpha, sine of alpha, cos of beta. Oh, wait, I'm reading it out of order. Tan of alpha, cos of alpha, sine of alpha. Tan of beta, cos of beta, sine of beta. So let's see. We can start with tan. So the first question says, what is tan of alpha? I've got alpha over here. I know that the trigonometric ratio for tan is opposite over adjacent. The opposite of alpha is unknown, so I'm going to use, yes, you've guessed correctly. The theorem of Pythagoras says side square plus side square equals hypotenuse square. I am looking for a side, so I'm going to say side square is equal to hypotenuse squared minus side squared. Oh my gosh, Mrs. Venti, what did you do? I said minus side squared on both sides. So let's substitute. What I'm looking for is the unknown, so I keep that as side squared. My hypotenuse is 3. 3 squared minus square root of 5 squared. Interesting. So side squared is equal to 3 times 3 is 9 minus square root of 5 squared. I just want to remind you that the square root and the square sign cancel each other out. So the square root of 5 squared is actually equal to just 5. Or square root of 5 times square root of 5 is equal to 5. So side squared is equal to 9 minus 5. 9 minus 5 is equal to 4. In order to get s alone, I square root both sides. It's exactly what we did over here. So square it on both sides. So s is equal to 2. I now know that this side is equal to 2. Back to my original question. Tan of alpha is equal to opposite. My opposite is going to be 2 over adjacent, which is going to be square root of 5. It's not 3 because 3 is the hypotenuse. That is tan of alpha. Next question is, what is cos of alpha? So cos of alpha is going to be adjacent over hypotenuse. Adjacent is square root of 5 over hypotenuse of 3. And sine of alpha is going to be opposite over hypotenuse, which is going to be 2 over 3. Those are the trig ratio values for the angle of alpha. Now we do the same thing, but for beta. So tan of beta is going to be opposite over adjacent. Opposite over adjacent, where adjacent, remember this side is going to be your hypotenuse. I made a mistake now. So this here is your adjacent. Adjacent is 2 over square root of 5. Okay. Cos of beta is going to be adjacent over hypotenuse. We said adjacent is 2 over hypotenuse of 3. And lastly, sine of beta is going to be opposite over hypotenuse, and that is equal to opposite of beta is square root of 5, and your hypotenuse is 3. That is the answer to question E. We have one more to go, and that is question F. Then we're done with this exercise. Question F says, the right angle triangle has the sides of the length A, B, and C units. The angles alpha and beta are shown. The third angle that they don't say anything about is 90 degrees. Now the question says, write down the values of sine, cos, tan of theta, sine, cos, tan of alpha. All right, let's mix it up a little bit. I'm going to do both signs together. So let's say sine of alpha, let's start with theta. Sine of theta is equal to opposite over hypotenuse. If this is theta, then my opposite is going to be C, and my hypotenuse is A. That is sine of theta. What is sine of alpha? Sine of alpha is also opposite over hypotenuse, but my opposite is different. If this is alpha, then my opposite is going to be B. So sine of alpha is going to be B over hypotenuse, which is valued at A. B over A. Next up, let's do cos of theta and cos of alpha. Cos of theta is adjacent over hypotenuse. Cos of alpha is adjacent over hypotenuse. But adjacent to what? Cos of theta, here's theta. So what is adjacent? Adjacent is the line that forms part of the angle. Notice the other line is the hypotenuse. So it's not the hypotenuse, it's the line that's not named. So that becomes B over hypotenuse is A. Same thing when it comes to alpha. We've got the hypotenuse on one side and we've got adjacent on the other. Adjacent is C over hypotenuse A. And then lastly, tan of theta and tan of alpha. Tan is opposite over adjacent, opposite over adjacent. Opposite of alpha is C, over adjacent of alpha is B, and opposite of alpha, the first one was theta. Opposite of theta is C over B. Opposite of alpha is B over adjacent is C. So that's interesting. That is the end of exercise 1 on page 164. I hope this helped you. I hope it makes sense. Please like and subscribe. I will see you for the next video. All the best. Thank you for watching.